Okay, so this is lesson 3 in our trig unit, and we're going to start by reviewing what we did in the last lesson, and then this lesson is about actually making that meaningful, like why the last lesson didn't seem to have a whole lot of point. This lesson, we actually use that to do something, to actually solve some problems. So the first question here just says to set up the trig ratios for the following triangle, calculate to 4 decimal places. Okay, so when it says trig ratios, what it means when it says that is our SOHCAHTOA stuff. Okay, that's our sine ratio, our cosine ratio, and our tangent ratio. These are on your formula sheet. The easy way to to memorize them is not very hard because there is this SOHCAHTOA. Okay, this, if you can remember SOHCAHTOA, then you don't even need to use your formula sheet. But let's take a look at what is on the formula sheet. Okay, on your formula sheet, it has Pythagoras' theorem, which we used in lesson 1. But what we care about here is the trig ratios, the trigonometric ratios. So this is sine of an angle is opposite over hypotenuse, cos of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. So that is what I just wrote out with our SOHCAHTOA. Okay, sine S is opposite over hypotenuse. S for sine, O for opposite, H for hypotenuse. This first letter, the first letter is always the ratio, like sine, cos, or tangent. The second letter is always the one that's on the top of the fraction, and then the third letter is always the one that's on the bottom. So sine is opposite over hypotenuse. Ka is cosine is adjacent over hypotenuse, and toa is tangent is opposite over adjacent. Okay. So that first example says it wants us to set up the trig ratios, sine, cosine, and tangent, for the following triangle. So it wants us to do this for both of the angles. We're just going to do this one here. Okay, we're going to start by just doing the 36.87 one. So that means if we're looking from this angle, okay, if we're talking about this angle, like for us to do the sine ratio of 36.87 degrees, then we need to look at our sides from this. It's like as if we're standing over here, and this is our reference angle. So the hypotenuse is always the same no matter what. It's always right across from the 90-degree angle. So whatever is right across from the 90, straight across, not touching it, is the hypotenuse. So I write HYP to stand for hypotenuse. Opposite and adjacent depend on what angle we're talking about. So because we're talking about this angle, it is directly across. This is our opposite. It is opposite from this angle, it's not touching it. And adjacent means beside. So the only one left is the adjacent one. The hypotenuse is also beside it, but the hypotenuse is different. Okay, it's the one that's across from the 90. The one that's left is the adjacent, the one that's beside. So now if we want to set up our sine ratio, sine is opposite over hypotenuse. If we look at our formula sheet, sine of an angle, okay, so this is our like 36-ish degrees or whatever, is the ratio, the comparison of how big the opposite side is compared to the hypotenuse. So we're just going to write that in. We're going to write in our opposite, and we're going to write in our hypotenuse. Is equal to the opposite over the hypotenuse. So on the top of our fraction goes the opposite, which is 3. And on the bottom of our fraction goes the hypotenuse, and that is 5. So it said it wanted us to calculate it to 4 decimal places. So sine of the angle 36.87 degrees is 3 over 5. So in our calculator, we're just going to say 3 divided by 5. This is what it's going to look like in your calculator. 3 divided by 5. Take the top number and always divide it by the one on the bottom, just like this. Okay, so now when you do that, 3 divided by 5, you will get 0.6. Okay. So what that means is that the sine ratio for this angle that we're talking about, this angle, is equal to 3 divided by 5, which is also equal to 0.6. So the sine ratio for this is 0.6. So we figured out from this triangle but your calculator also has these things memorized. It knows what the sine ratio of 36.87 degrees is. So if in your calculator you press the sine button, so I'm going to make it, screen go back here for a second. So in your calculator, there's a sine button. Your calculator might be slightly different, but as long as you have a somewhat scientific calculator, you'll have a sine button. So you press the sine button and up pops sine. And then if you put in 36.87 degrees, 36.87 degrees, and I just close my bracket there. It'll still work if you don't close the bracket, but I put it in there just to look nice. I press enter. It gives me 0.6000001, but like if we're going to round, it's 0.6. And the reason why it does have like that extra long decimal there is because your calculator is giving you a slight approximation, whereas what we did here gives us the like exact answer. But we're going to round it to 0.6, which is exactly what we just found. So because our calculator knows these things, we can then use this to figure out missing sides in a triangle. If we know the angle and we know one side, then we can find out a missing side. Okay, so down here it asks us then to calculate the following to 4 decimal places. So this is what we just did. We said, without putting in the numbers for the sides, even if we didn't know what those side lengths were, if we wanted to know what is that sine 36.87, sine ratio for that angle, we put it into our calculator and it gave us that 0.6. We didn't need to do this part. Okay, and we could do the same thing for all of these. Okay, cosine ratio is the adjacent over the hypotenuse, and that would be 4 over 5. And if we put it into our calculator, we would get the exact same answer. So I'm just going to do the next one. I'm going to put the next one up without going through it, but I'm not going to go through each one. If you want to take the time to do that yourself, you can, but I think it would just take a little bit too long to go through each one. So let me do this part for you. All right, so I just set up the cosine ratio here. If you want to copy this down, you can. The cosine ratio for that angle, so still talking about this one, is the adjacent over the hypotenuse. And so the adjacent was 4, the hypotenuse was 5, and 4 divided by 5 in your calculator gives you 0.8. So this 0.8 is what the ratio is for that angle. If we do that exact same thing and put it into our calculator, okay, I took cos of that angle. I didn't have to use the side lengths at all. I just said cos of that angle. It gave me 7.99999. We would round that up to 0.8, okay, which is exactly what we just found there as well. So if we just took this and put it into our calculator, we would get the same thing, 0.8. Okay, exact same thing. So now let's use that to solve some problems. This here is a brief refresher on how to manipulate equations to solve for x. Okay, I'm going to go through these 3 examples, but I'll make a separate video that goes through this in more detail. If you're not understanding just from this, then I'll try to put a link in to that video as well. So for this, when we're going to have to do this in the next part of the problem. So these are just some examples of how to solve for x. If we want to know what is x, what is the net value of x? Is it 2? Is it 7? Whatever. Then the way we do that is we need to get x by itself is equal to something, right? If we found out that x was equal to 2 over 4, then we could just say 2 over 4 in our calculator, and that would show us that x is equal to 0.5, and that would solve it for us. Okay, but the goal is always to get x by itself, and it also has to be on the top. Okay, what I mean by that is that right here, we have x on the bottom of a fraction. Okay, we want x to be on the top. If you see something like this, where it's just a number and there's no fraction, if there's ever a number with no fraction, we still consider that to be the top. Okay, if we were going to draw a fraction, we would draw the line below it, and so we would still consider this to be the top. So let's do this as an example now. If you want to get x by itself and on the top, it's currently on the top of the fraction. That part's good. And we don't care which side it's on. We could have x is equal to something over here, or we could have x is equal to on this side, and we have something over here. Either way is fine. Right now we have x on the right-hand side, and that's fine. It's on the top. We just need to get rid of this 10. So the way we do that is, right now we have x being divided by 10. To get rid of it, we need to multiply by 10. If we multiply x by 10, then we will have 10 divided by 10 is just 1, and these things will cancel. Great. Okay, so we multiplied by 10. We did the opposite of what was being done, and we canceled them out. But anything we do to this side over here, we have to do to the other side. So as a totally separate example, I'm going to use a different color here and do it over here to try and not get confusing. If I say that 5 is equal to 5, okay, everyone would agree. 5 is 5. That's what it is. If I were to double one side of this equation, now this side's equal to 10. If I want to make this still true, if this is still to be true, that this side is equal to this side, I need to do the exact same thing over here. Otherwise, I would have 10 is equal to 5. So if I double this side, I need to double that side. Now this is still true. It's still 10 is equal to 10. If I want to divide one side, let's say now I want to divide this side by 2. Okay, 10 divided by 2. I need to do the exact same thing to the other side. I need to divide the other side by 2. That way, everything will stay true. It's still 5 is equal to 5. So what I did over here, okay, going back to this problem, is I multiplied this side by 10, which is the opposite of dividing by 10. If I do that, I need to multiply this side by 10 as well. So we multiply, we put it on the top. And you can either put these things in brackets to show they're being multiplied, or you can draw an x to show they're being multiplied, but it can get confusing because we are using an x here. So I'm just going to draw brackets to show that this is like 10 being multiplied by 0.5. So now we have 10 divided by 10 cancels. Anytime there's the same thing on the top and bottom of a fraction, they're going to cancel like that. And that leaves us with this. 10 times 0.5 is equal to x. Now it's easy. Now we just need to put this into our calculator. 10 times 0.5. Okay, you could do it with brackets, or you could say multiply. Either way is fine. But 10 times 0.5 is 5. And so 5 is equal to x. And we're done. Now, I'm going to do these last two the long way, like I just did. And then I'll show you the trick that makes it a lot faster. Okay. This one, actually, let's do C first. Okay. So x is on the top right now. That's good. It's on the top of a fraction, but it's not by itself. We need to get rid of this 5 on the bottom. Okay, right now x is being divided by 5, so we need to do the opposite. Okay, to do the opposite, we need to multiply this side by 5 so that these ones will cancel. So we multiplied this side by 5, but now we need to multiply this other side by 5. So that goes on the top of the fraction. We multiply, it goes on the top. 5 times 3 is like the top of our fraction and being divided by 2. So those cancel, and we're left with 5 times 3 divided by 2 is equal to x. So in your calculator, you're multiplying the things that are on the top and then dividing by what's on the bottom. So this would be like 5 times 3 divided by 2, so 15 divided by 2 is 7.5 is equal to x. Now, let me show you the trick that makes this really easy. Okay. What happens when we multiply both sides like this? Okay, we canceled out, what we had is we had this 5 on the bottom of this side, and it ended up going to the top of the other side. Okay. On this example over here, we had a 10 on the bottom, and after we multiplied, what ended up happening was that it went up to the top of the other side. This is the rule. As long as you just have like numbers being multiplied and divided with an equal sign, as long as there's no adding or subtracting or anything like that, you can move things diagonal across an equal sign. Okay, meaning like if you have a fraction, you can take something from the bottom of one fraction and move it to the top of the other side. If you have something on the top of a fraction, you can move it down to the bottom. So if there's something up here, sorry. If there was something on the top of a fraction, you could move it down to the bottom of the other side. And the same goes for this side. If there's something on the top of this side, and I want to get rid of it, I can move it down to the bottom of the other side. Okay, this works because of what I just showed you here. This was like showing why it works and the steps of how it works. But the result is that you can basically just kind of drag and drop things from the top of one side to the bottom of another. So let's now use that idea of like being able to move diagonal across an equal sign with this problem here. Okay, let me clean that up a little bit. Okay, you can move diagonal across an equal sign like this. Okay, so we need to get x on the top. It's currently on the bottom. So we're going to take it and we can move it diagonal across the equal sign to the top of the other one. Remember I said if there's no fraction here, like there was nothing down here, but this is still considered the top. So we're taking it from the bottom of this one and moving it over to the top of that side. So x is being moved up and we are left with x times 5 on this side. I'm just going to put it in brackets. X times 5 on that side is equal to 20. So now we've got x on the top, but we need to get rid of this 5. So how we can do that, we're going to move it over to the other side. It's on the top right now. We need to move it to the bottom. We need to take it and move it diagonal down to the bottom of the other side, down here. Okay. So 5 is being moved to the bottom, and then we now have x is equal to 20 is on the top, and 5 has been moved down to the bottom like this. X is equal to 20 divided by 5. So if you take 20 divided by 5 in your calculator, it will equal 4, and that's our final answer. X is equal to 4. So let me quickly show you this now. These become very quick. If we want x on the top, it already is. That's good. But we need it by itself, so we take this 50, move it diagonal up to the top there. This is 50 times 0.25 is equal to x. Put it in your calculator. This one, x needs to be on the top. It's currently on the bottom. So move it up to the top of the other side, and we need to get rid of that one. So we're going to take it and move it down to the bottom. If we did it all in one step, these things just switch places. I can show it to you in 2 steps, but x times 2.5 is equal to 15. Take that, move it to the bottom. X is equal to 15 divided by 2.5. Lastly, x is on the top already, but we need to get rid of the 15 and move it diagonal up to the top. So this becomes, 15 times 7 divided by 4 is equal to x. Okay, and I was saying that I typically don't like writing multiplication signs here because they look like x's. I normally use brackets. So 15 times 7 divided by 4 in your calculator gives you your final answer. So this is going to be a bit of a longer video because I'm kind of reviewing that kind of stuff. But now we can use that combined with our sine stuff. So it says set up the sine ratio using the angle 52 degrees. Okay. If you need to take a quick break after that to like refresh before coming back to that's fine. So, but moving on, we want the sine ratio using this angle 52 degrees right here. Okay, we're looking from here. So this side is opposite. Hypotenuse is across from the 90. This is hypotenuse. This side is adjacent, but we don't know the number there and we're not looking for it. So we don't really care about this side right now. So it says it wants us to set it up. So sine, remember if we use our SOHCAHTOA, sine is opposite over hypotenuse. So sine of our angle 52 degrees is equal to the opposite. This is what goes on the top of the fraction. Opposite is on the top and hypotenuse is on the bottom. So our opposite side we don't know, it's x. And our hypotenuse is 14.2. So we've set it up, but we're missing something. Now the question says solve for x. Now we can actually do something useful with this trigonometry stuff. So we're going to take our 14.2 and we need to move it to the top of the other side. We want to get x by itself and on the top. It's on the top, but we need to get rid of this. So we're going to move it diagonal to the top over here. And all that happens is it just is 14.2 times what we had here, sine 52 degrees is equal to x. And we put that into our calculator and we're done. And it looks basically exactly like that. So I'll show it on my calculator just so you can see it. I have sine 52. Okay. Reminder, your calculator needs to be in radian mode. So what I have here is 14.25 times sine 52. You can write a multiplication symbol between the 14.25 and the sine if you want, but either way, it's going to give you the same answer, which was 11.2 229. So I'm just going to say 11.2.